Hello students, let's see number system. So what is number? Number is an arithmetic value that represents a quantity. Now what is number system? It is an arrangement to represent numbers. Now numbers have been classified into various categories. First of them is natural number. So natural numbers are called counting numbers, like 1, 2, 3, 4, 5 and so on. In natural number comes prime number and composite number. Prime number is a number which has two factors. First factor is 1 and the other factor is itself. For example, 2, 3, 5, 7, 11, 13. These all have two factors and one factor is themselves. Important point to remember is only 2 is the only even prime number and 2 is also a smallest prime number. Now come to composite number. Natural number greater than 1 which have more than two factors. So composite number is a number which have more than two factors. For example, 4, 6, 8, 9, 10, 12. So take all the natural number greater than 1 and subtract prime number from them. So you'll get collection of composite numbers. Now co-prime. When two numbers are said to be co-prime when their HCF is 1. Like 2, 3, 4, 7. They have HCF is equal to 1. But 10 and 12, their HCF will not be 1. Because if we divide 10 by 2, we get 5. And if we divide 12 from 2, we get 6. So HCF will be 2. So this is not a co-prime. Now let's come to twin prime number. When two prime numbers whose difference is 2, then it is called a twin prime number. How to check whether a number is prime or not? Oh yeah, this is also important. Let's say that you have a number 27 and you want to check whether it is a prime or not. So there are 3 steps for this. First, take the root of that number. The root of that number, like for example, root of 27 is approx 5. Approx 5. So numbers smaller than this number, like 2, 3, are easily able to divide 27. So 27 will not be a prime number. Now take a second question. Take a second question, like take a second number as 17. We know that the nearest perfect square near root 17 is root 16. That is equal to 4. And the number lesser than 4, like 2, 3, are not able to divide 17. So 17 is not divisible by any of these numbers. So 17 is a prime. Let's take one other example. Let's say 101. The closest perfect square number near under root 101 is under root 100, which gives value 10. Now numbers less than 10, like 2, 3, 5, 7, they cannot divide 101. So 101 is a prime number. So I hope you got me. Now, what is whole number? Whole number is a number. Whole number is natural number plus 0. If we include 0 in the natural number, the 0 added to the whole of natural number is whole number. For example, 0, 1, 2, 3, 4, 5 and so on. Integer. Integer comes from the word zehlein. Jahlen, which means to count. Now, we know that on a number line there is 0, and in the right side, we have it is right for me. On the right side, we have negative numbers. On the left side, we have positive numbers. So, all these number which can be represented on the number line are called integers. We'll get into the more detail in times ahead. So 0, 1, 2, 3, 4. If from 1 to infinity, we call this I positive, means positive integer. And if we include 0, then we call it non-negative integer or whole number. If we take only the negative integers, we call it negative integer. And if we take only the negative numbers, we also call it non-positive integer. So 0 is neither positive nor negative. Let's come to a rational number. What is a rational number? Rational number, the number which can be represented in the form of p by q, or in some books given m by n, where p and q, m and n are integers and q is not equal to 0. So, like for example, 2 by 3. Here p is 2, q is 3, and we know that 3 is not equal to 0. In the same way, these all are rational number. The questions that are popular in books are how to find rational number between two numbers. For example, find 5 rational number between 7 and 8. In order to find the 5 rational number, we are this is the first method. So in order to find the rational number between these two numbers, we must make it into a form of a fraction in which their denominator is same. In order to make them into a fraction where denominator are same, and if you want to find the 5 rational number, then 7 will be multiplied and divided by 6, and 8 will also be multiplied and divided by 6. So we get 42 by 8 and 42 by 6 and 48 by 6. And in between these two, 43, 44, 45, 46, 47 by 6 are the rational numbers present between 7 and 8. Next question comes. We have to find 7 rational number between 4 and 5. So 4 and 5. We have to find the 7 rational number. So in order to find the 7 rational number, we must multiply it with a number greater than 7. So 4 into 8 divided by 8, 5 into 8 divided by 8. So 8 4 is 32 by 8 and 5 is 40 by 8. In between these two, we can get 7 rational numbers. Let's move on to another question. We have to find the 5 rational number between 4 by 5 and 6 by 5. How will we find? We will simply multiply both the denominator and numerator by number greater than this, that is 6. Multiply it by 6 and divide it by 6. Multiply it by 6 and divide it by 6. We get 24 by 30, 36 by 30. And we can find the rational number between them. Next question. Here, we have to find 4 rational number, but the twist is that here the denominator are not same. So first what we will do, we will make the denominator equal. In order to make it equal, we will multiply these two with the denominator and multiply these two with the denominator of first fraction. After multiplying, we will get 4 by 5, 4 by 6 and 9 by 6. And now when the denominator are same in both the numbers, we can follow the method like we have done here. We need 4 rational number, so we will multiply it by 5 and divide it by 5. Multiply it by 5 divided by 5. 21 by 30, 22 by 30, 24 by 30, 25 by 30 is the rational number that I need. That we needed. Now this question says that find 5 rational number between 3 by 4 and 5 by 4. 4 by 5. The first thing to do will be make the denominator of both the fraction equal. After making them equal, multiply it by a number greater than 5, just one greater than 5. So it will be 6. So 15 into 6 by 20 into 6 and 16 into 6 by 20 into 6, we will get 90 upon 120, 96 upon 120, 91 upon 120, 91, 92, 93, 94, 95 and all that. Method 2. In the second method, this is the second method. Here denominator must be same. So what we will do is, let's say we have to find the rational number between 4 and 5. We will simply multiply it by 10 and divide it by 10. And again multiply it by 10 and divide it by 10. We will get 40 upon 10, 50 upon 10. And in between we can find the rational numbers. The next and important method is average method. If we have to find the rational number between 4 and 5, simply add them and divide it by 2. So 4 plus 5 is equal by divided by 2 is equal to 9 by 2, and 4.5 will be the rational number between 4 and 5. After getting that, suppose that we don't want to find 1, we want to find more. So 4 plus 9 by 2 divided by 2 we'll get 17 by 4. And after getting 17 by 4, if you want more, then we will take the number 4 and then add it to 17 by 4 and we'll divide it by 2 and we'll get another rational number. So this is how we can keep finding out the rational numbers between this rational numbers. Now let's solve few questions. Like for questions like 2 by 11, we have to express this fraction into a decimal number. So the process goes as follows. We will divide 2 by 11. When we divide, we all know the division method, so I'll not go in that much detail, but we will first we'll put 0 and point. After putting point, we'll add 0 here, and we know that 11 1 is equal to 11, and we'll get remainder as 9. So we know that 9 is smaller than 11, so we have to make it bigger now. So we have already put the point, so we'll add 0 over here, and then 11 8s are 88, so 90 minus 88 we get 2, and we have already put the point, so we can add 0 over here. And now we'll see that 1 and 8 will come on repeating itself, will repeat itself in this quotient. So we'll put a bar over 1 and 8, which indicates that 1 and 8 will keep on repeating after decimal. So this is the answer. This is the decimal form of 2 by 11. Let's move forward to some word problems. For example, if x is a positive integer less than 100, then number of x which make under root 1 plus 2 plus 3 plus 4 plus x an integer. So we have to find the value which can make this an integer. So we'll sum this numbers like 4, 3, 2 and 1, we get 10. So under root 10 plus x, we have this number, and we want to find out the values of x which can make this number an integer. For example, if we put the value of x to be 1, will we get an integer? No, we will get under root 11, whose value will be in fraction. So possible value of x will be, okay, what will happen if you put number 90, we'll get a perfect root, perfect square of a perfect square. We'll get the perfect square. So if you put number 90, we'll get 100, and root 100 is equal to 10. So this will be a so this can be one value that we can take. Now another value we can take is 71. If you put the value of 71, we get 81, which is the square root of which is the square of 9. In the same way, we can add 54, 39, 26, 15, and 6. So if we do this by trial method, we will see that there are 7 values possible for this number. Now comes another question. The question says that the sum of 3 prime number is 100. If one of them exceeds another by 36, then one of the number is. So let's see. There are 3 prime numbers. How many prime numbers? 3 prime numbers. And their sum is equal to 100. And one more condition is given, that P1 is equal to the prime number 1 is greater than prime number 2, and the prime number 2 is greater than prime number 1 by 36. So P1 is greater than, let me be clear, let me repeat this again. Prime number 1 is greater than prime number 2 by 36. So in this equation, we'll put the value of P1. We'll get P2 plus 36 plus P2 plus P3 is equal to 100. Now after solving it further, we get 2P plus P3 is equal to 64. Now we'll take the value of P3 to be 64 minus 2P. And now again we know the value of P2 is how much? 36. Wait a second. We'll get the value of P2. P2 is how much? After solving P3, we get 64 minus 2P2. So P3 will become, if we take the common from both the terms, we get 2 multiplied by, in bracket, 32 minus P2. Now again, we know that P3 is multiple of 2. P3 is a multiple of 2, and there is only one prime number which is a multiple of 2 that is even, is 2 itself. So the P3 is equal to 3. So we have found the one prime number. Let's move ahead. Choose a number, rational number, which does not lie between minus 2.2 upon 5 and minus 1 upon 5. The number which will not lie between minus 2 upon 5 and minus 1 upon 5 will be 3 by 10, because, let me tell you this, because whichever number will lie between these two will be negative number, and in the options there is only one positive number. So this will not lie in between minus 2 by 5 and minus 1 upon 5.